Hello, you're right, Mrs. Connor here. Welcome to today's lesson. If you could please rule off where you got to last lesson, write the date and the title, make sure you underline both, and then have a go at this do now task where it's just recapping your knowledge, making sure it's still there, it's still firm, to do with multiplying and dividing indices with the same base number or the base value. Please pause the video as you do this. Brilliant, good. So here we should know that if we're multiplying indices with the same base value, we just actually add them. Okay, so 5 to the power of 5 times 5 to the power of 5 is actually 5 to the power of 10. So we have 5 to the power of 10 here. Then we have 5 to the power of 10 again. Then we have 3 to the power of 13 because it's 2, add 4, add 7. Then we have 10 to the power of 6. Now remember, 10 on its own is equivalent to 10 to the power of 1, so don't miss that 1 even though it's not written. Then we're going to look at a division here. So we do 11, subtract 7, subtract 2, so it's 5 to the power of 2. And then here, the misconception is that students will put 8a to the power of 8, but because one power is inside the brackets and one is outside, we actually multiply those two indices there. So we actually get a to the power of 15, so here you get a to the power of 14, a to the power of 36, and a to the power of 81. Please make sure you've marked your work as we've gone through and make any corrections where necessary. Right, brilliant. So our success criteria today is to recall and apply the process of using negative powers of 10. That's something you've looked at earlier on in this topic. To be able to apply negative indices to solve problems and to understand the links between inverse operations and negative indices. So a lot of deeper level thinking here today. This is our hook question today. We'll have a quick read of it. We're not going to do it now. This is something we'll come back to at the end of the lesson, that once we've been through today's work and today's learning, you should be able to access really easily. Okay, so first things first is a recap slide. So again, you've looked at this earlier on in the topic. So we're going to calculate this idea of 10 to the power of negative 1. So you'll notice our exponent here this time is a negative 1 rather than a positive 1. And when you're doing using a negative exponent, you actually turn your calculation into 1 as your numerator and then 10 to the power of positive 1 as your denominator. So you flip this into a positive, but then you put it underneath a 1 as a fraction. So actually 10 to the power of negative 1 is equivalent to 1 over 10 to the power of 1, and we should know that 10 to the power of 1 just means 10, and if we wrote it as a decimal it would be 0.1. Then we've got this idea of 10 to the power of negative 2, so our exponent here is a negative 2, so we could write this as a fraction of 1 over 10 to the power of positive 2. We know 10 to the power of 2 actually means 10 times 10, which is 100, which would be equivalent to 0.01, and then we can think about what would our answers look like if we left them as a fraction, because actually it might make more sense to do that unless we're specifically told to write them as a decimal. So we should know that actually 0.1 is equivalent to 1/10 because we know 10 to the power of 1 is just 10. So if we look at this one here, it's going to be 1 over something. Well, the something will be 100 because 10 squared is equivalent to 10 times 10. If you could please copy down these taught examples for me, and then have a go at these calculations in your exercise book. Leave your answer as a fraction at the end and make sure you show the stages as they have been shown here. Please pause the video as you do this. Right, good. So we should have 1 over 10 to the power of positive 3, which is 1 over 1,000, 1 over 10 to the power of positive 4, which is 10,000, and 1 over 10 to the power of positive 5, which is 1 over 100,000. So just check these, make sure you've got them right, make alterations if you need to. Right, good. The first thing I would like you to do, because you may not have done it for that first task, is just to get your calculator for me. You'll be using it at times today, and just try and work out how to input negative indices. So what I would like you to do first is just put the number 2 in, okay? And then if you want to, you can pause the video and see if you can work out how to put negative indices, or you can just follow my instructions now. So you're looking for this button here. If you've got one of the more modern calculators, that's what you're looking for, an X with an empty white box. If you press that, you then have the option to type in a power, and you can type negative 1. I would like you to do that for me, and you should then get an answer of a half. You can go back and put 2 to the power of negative 2 if you want to, and you should get an answer of a quarter, and you can see how that works. Okay, now what we're going to look at here is these two problems. So we've got 5 to the power of 2 and 5 to the power of negative 2. Now what's the same is quite obvious. There's a 2 in both, and the base value is 5. But what's different is you've got the positive exponent and the negative exponent. Now we know that actually 5 to the power of 2, the exponent, so the indice, just tells you how many times to multiply the number. Okay, whereas when you have a negative exponent, it tells you how many times to divide the number, and that should make sense because the opposite to multiplication is division. So when you've got a negative exponent, that's actually what you're doing, and that's why the number you end up with as your answer is actually smaller than the base value. So 2 to the power of negative 1 is a half, whereas 2 to the power of 1 will be 2, because with 1 you're multiplying and with 1 you're actually doing repeated division. Okay. Right, I would like to have a quick look at this, something you will have seen before. And just, do you notice a pattern or a link between positive and negative indices? Just pause the video whilst you have a think about this. Right, good. I'm hoping what you've done is you've spotted links here between 2 to the power of 1 and 2 to the power of negative 1, 2 to the power of 2 and 2 to the power of negative 2, and so on. And you'll see that actually you've got 2 to the power of 1 as 2, and 2 to the power of negative 1 is 1 over 2. 2 to the power of 2 is 4, and 2 to the power of negative 2 is 1 over 4, and that pattern follows on, okay? And the general rule that you need to follow is, when you have a base value to a negative power, you just have to do the inverse, okay? So the reciprocal, so you turn it into a fraction over 1, and you have the same base value, but you turn your power into a positive, the positive version. So if it was a to the power of negative 3 here, it would be a to the power of positive 3 here. What I would like you to do is pause the video and just copy down this here so you can see the link, and copy down the general rule for me. Please pause the video. Right, brilliant. Okay, so we're going to have a look at other numbers we can use with negative exponents, so negative powers. So first we're going to calculate 2 to the power of negative 1. Which we now know we can write as a fraction as 1 over 2 over 1, okay? Sorry, not 1 over 2 over 1, 1 over 2 to the power of 1. We should know that 2 to the power of 1 is just equivalent to 2, so our answer is a half, okay? And if we look at 5 to the power of negative 1, well, we know that we can write that as a fraction as 1 over 5 to the power of positive 1, and again, any number to the power of 1 is just itself, so your answer is actually 1/5. Okay, you might be asked to write the answer as decimals. That's really simple. If you're using a calculator, you'd have 0.5 and 0.2. What I would like you to do is copy down these taught examples in your exercise book and then calculate the following, and be sure to show each stage of working just as we have here. Even if you think this is straightforward, it's good for you to get well worked examples down, so when you look back at it in 2-3 months, whatever it might be, you can see what you've done. Please pause the video as you do this. Right, brilliant. So for A, you should have a fraction of 1 over 4 to the power of 1, which is a quarter. Then here you should have a fraction as 1 over 6 to the power of 1, which is a sixth. Then a fraction as 1 over 8 to the power of 1, which is 1/8. And then a fraction of 1 over 11 to the power of 1, which is 1/11. Please just mark your work, make any corrections where necessary. Right, if you are still thinking I'm a little bit unsure, I maybe need explaining in a different way, there is a YouTube video here that you can watch. Now, if you go onto the regular PowerPoint, which you can get from the college website in the weekly resources, you could just click on this, and it's by Mr. Corbett, and he's brilliant. Now, it's a 2.5-minute video. You only need to watch up to 1 minute and 17 seconds, and he just gives you another run through of how we work with negative indices. If you're still not quite sure, obviously you can go back through the video and watch our examples again together, or you can have a look at this video here. Okay, right, we're going to look at the next stage, so not just powers of -1, but other negative powers, so other negative exponents. So this time we've got 3 to the power of -3. Now the general rule is still the same. You turn it into a fraction over 1 and 3 to the power of +3. But we know that that actually means 3 times 3 times 3, which is 27, because 3 times 3 is 9, 9 times 3 is 27, so you write it as 1 over 27. We can see here that 2 to the power of -5, again we can write it as 1 over 2 to the power of 5, and we know that that actually means 2 times 2 times 2 times 2 times 2, which gets us 1 over 32. Now you'll notice that the greater the negative exponent, so if you did 3 to the power of negative 1, you'd get 1 over 3 as your fraction, whereas 3 to the power of negative 2, you'd get 1 over 9, and 3 to the power of negative 3, you'd get 1 over 27. And what that shows is the greater the negative exponent, the smaller the value is of your answer, because remember, it's repeated division actually is what's happening, okay? So can you copy down the taught examples in your exercise book and then calculate the following, and just be sure to show each stage of your working. And actually what we talked about here with the greater the negative power, the smaller the answer at the end, you can make that comparison here with the example we've already done and what you get here, and then also with the example we've done together and the answer you get here. So please pause the video as you copy these down and have a go at those examples. Splendid. So we should have 1 over 2 to the power of 4, which gets us 1/16, and we can see here that 1/16 of a pizza, for example, is more than 1 over 32 of a pizza. So actually that's smaller, that's worth less than this, which again shows this idea that the smaller the exponent, the bigger the answer, or the bigger the exponent, the smaller the answer. Right, 3 to the power of negative 4 is 1 over 3 to the power of 4, which is 3 times 3 times 3 times 3, which gets us 81. And then we've got 4 to the power of negative 3, which is 1 over 4 to the power of 3, which is 4 times 4 times 4, which is 1 over 64. And then we've got 1 over 5 to the power of 3, which is 5 times 5 times 5, which is 1 over 125. Please just mark your work as we go through and just make any corrections where necessary. Right, brilliant. You've got lots of standard examples to work through here. Please pause the video as you work out the correct answers to them. You can leave them in fraction form. You don't need to turn them to decimals. Please pause the video as you do this. Brilliant, good. We'll just fly through some answers so you can mark your work, have your marking pen ready. So we should have these as our answers, and some of these you'll have seen before in our practice questions. Keep an eye out. It's aha. So here we've got a mistake. So it should be 1 over 9 to the power of 2, so it should be 1 over 81. So just be aware of that, okay? Well spotted, miss. And then here are our other answers. If you spot any other slight errors, you can be very smug about it and you can email Mrs. Connor directly about them to tell me, and I will hang my head in shame. But I think that's the only one on this slide. Right, good. We're going to have an investigate task here. I would like you to have a quick look at it. So Mo, Alex, Rosie and Tommy are working out 2 to the power of negative 3. They all have a different answer. So the A part to this, the simple bit, is who is correct. You should just be able to work that out now. The harder bit is this section here. Explain the mistakes that have been made by the others. So please pause the video and take your time and have a go at solving this investigation. Right, good. I'm hoping we all got the first part of who is correct. So it's Rosie, it's 1/8, because we know that 2 to negative 3 we can write as 1 over 2 to the power of 3. 2 times 2 times 2 is 8, so it's 1/8. But the difficult bit is where have these gone wrong? Because it's important that we understand this idea of misconceptions and what shouldn't I do and why have they made that mistake. So Mo here, he's just done 2 times negative 3. Okay, and he's got negative 6. Here, Alex is on the right lines actually, but he's just forgotten that actually when you write a negative exponent as a fraction, it becomes the positive version, okay? So denominator is a negative and not a positive. And then here again, Tommy did 2 times negative 3, which you can understand, that misconception, and then just made it the denominator. So Alex was the closest, but no cigar, but Rosie was spot on. Right, good. Next thing here, so another investigation. You'd like to sort these cards into ascending order, so biggest to smallest, and then you can check your answers using a calculator. So my advice would be maybe to convert them all into fractions or whole numbers and then put them in order. Please pause the video as you do this. Right, good. So the first thing I did is I went with the positive powers and just converted them into whole values, so 8 and 9, and then I converted the other negative exponents into fractions, and then it's quite simple to see, right, I can put those biggest to smallest. So the first one is the 9 for 3 squared, and then it's the 8 for 2 cubed, and then we've got 1 to the power of negative 10 and 1 to the power of negative 1. Well, they're both 1. Because here it doesn't matter how many times you multiply 1 by itself, you're going to get 1, okay? And then this is where misconceptions happen, because students will see a 9 and they'll go, yep, that's biggest. Think about it as something visual. Think about a pizza. If you eat a quarter or an eighth or a ninth of the pizza, when are you eating more? Well, if you eat a quarter, you're eating more, aren't you? So that's the next biggest value, and then it's an eighth, and then it's a ninth. And if you're unsure, check these fractions as decimals. Do 1 divided by 4, 1 divided by 8, 1 divided by 9, and then you can see how that comparison works. Right, good. We're going to quickly go through our true or false together. So the following is correct. 2 to the power of negative 2 equals 1/4. Is it true or false? Well, it's true. The following is correct. 5 to the power of negative 3 equals 1 over minus 125. Is it true or false? Well, it's false, because actually it should be a positive 129, because it becomes 1 over 5 to the power of 3, and then 5 times 5 times 5 is 125. To change a negative exponent to a positive one, flip it into the reciprocal. Absolutely you do. You make it a fraction over 1 with the positive exponent. The larger the negative exponent, the smaller the number it represents. Is that true or false? Well, it's true, because we've already talked about this fact that actually 2 to the power of negative 3 would be greater than 2 to the power of negative 6, because you get 1 over 8 and you get 1 over 64, and 1/8 is bigger than 1 over 64. And the last one, negative exponents represent repeated multiplication. Well, they don't, because that would imply that the bigger the exponent, the greater the number. We know that's not true. They actually represent repeated division. Right, I'll have another look at this hook question now. I'd like to pause the video and see if you can identify the mistakes that Sally has made and correct them. Please pause the video as you do this. Right, good. So first things first, you just spotted a mistake here. 4 to the power of negative 2 is not minus 16. It's equivalent to 1 over 4 to the power of 2, which is 1/16. And here she's just done 10 times negative 3, which is negative 30, and thought, well, but it's meant to be a positive, so it's just 30. But actually it isn't, because this fraction becomes 1 over 10 to the power of 3, and 10 times 10 times 10 is 1 over 1,000. Really well done if you got that. I'd expect the majority of you to be able to get that. Now that we've been through the lesson together. Right, good. Worksheets time. Please complete the worksheet on negative indices that you have. If you don't have it, it will be on the college website in the weekly resources. Well done, an absolute pleasure, and I'll see you next lesson.